Right, everybody, welcome to day 2 of LLM Ops. Today is the day where we're going to take our RAG and RACA, we're going to take our retrieval augmentation to the next level. That's what today's all about. The first couple things that we're going to do are associated with some of the feedback we've been getting, though. We want to make sure that everybody is good to go, everybody is squared away on where to find everything they need and where exactly those resources can be located, what those resources are. We're going to jump right in after we sort of go over some of the feedback that we've been getting, where we're going to talk about a little bit about what we've been learning over 2023. There's been a lot of people I've been talking to out there talking about, I took this course and I took that course and I took this and that, and I learned this and that, and I was kind of left wanting. We want to know kind of what you've been up to before you made it to this particular course right here. And we also heard you on setting up your dev environment. We're going to double down on making sure you are good to go after today. From LangChain 101 on Tuesday, we are heading into LangChain 201 today, and we have heard nothing but I want to build with agents, and that's what we're going to take a look at today. All right, let's see. So first off, I just want to make it really clear to everybody that we love your feedback. Thank you so much. We're getting a lot of feedback from people about setting up the dev environment. We're going to address this today. My environment, my dev environment. We want to make sure that we're ready to build when we get to class. We want to make sure that you're ready to build when you get to class too. Some people are having dependency issues. We don't want that to happen. And some people are asking for a little bit more on the READMEs, a little bit more on terms of architecture diagrams, a little bit more. And you know what? That's something that we want to be able to provide to you as well. So thank you so much. Continue to bring this feedback to us. We will continue to make improvements on the curriculum and on delivering it. And we're hearing quite a lot from people on topics we'd like to cover in the future. We're hearing LangChain and the deets. We're hearing Chainlit, Pinecone. And luckily, we've got some of this all ready to rock and roll for you. I'm going to show you exactly where to find it. And then we're hearing agents. Literally, we're tripling down on agents with multiple people across multiple pieces of feedback. So this is if there's anything as loud and clear as this, I haven't seen it yet. People want agents. And then there's a lot of excitement, a lot of sort of trepidation from people on this actually taking it from a prototype into production. And this is where eventually, if you're going to scale, you're going to have to pick up a cloud computing platform. AWS is still the one that people are going to basically start when they start thinking about cloud computing platforms. If you want to talk about AWS, we got the right guy in the room, pointing out Milan McGraw in the house tonight. He is a leader at AWS. If you're interested in learning more about his background, I encourage you to hit him up on Discord. Milan is a longtime supporter of what we've been doing, and we love having him. And you'll meet Milan in just due time, I'm sure. So we've got a lot of people interested in AWS, a lot of people interested in learning these deployment platforms. This is something, while it doesn't fit into the core curriculum, we are encouraging people to get together for community sessions and running them outside of the core curriculum. This is something that I think we've got a nice number of people that are interested in. Who knows? Maybe you'll see something pop up on your calendar in the not too distant future. And last but not least, people are asking, hey, can I get everything in one place? Yeah, that's been my biggest sort of how do we do this exactly right in Maven issue as we build in our learning management system. That means where to find the curriculum, where to find the recordings, where to find everything in Maven. So this is exactly what this is going to look like to you. When you click into Maven, you're going to be able to see different resources throughout the week. And we're going to kind of see this week 1 is going to pop up on the day that is associated with each week on Tuesday, and you're going to be able to click into that. over here is what happens when you click into it, and you'll be able to see the Zoom recordings, you'll be able to see the slides, and you'll be able to see the 2 assignments. The first assignment, shout out to Christos, who was crushing it in Discord already completed this thing like a straight legend, also shared it with everybody. Great job, Christos. That was the questioning Barbie reviews with RAG. And what we're going to do today is we're going to actually question some Barbenheimer reviews with RAG, get some dual streams going into the internet phenomenon of 2023 and see what we can learn if we actually ask it some interesting questions. We're also going to add some agents to the mix, agents. So we sent these resources out. I encourage you to look at them. There's a lot of stuff there. I want to kind of just leave it there for now. If you have questions, we're happy to dive in. And as we get further in, this is going to be a great place to look at some of these resources. All right. So with that, what we want to do is we want to go ahead and jump right in. It's time to meet some more people. We got a quick 10-minute breakout room, and there's a simple question we want you to ask and answer to one another. A lot of you are crazy lifelong learners, straight infinite learner status. You're always learning something. What LLM-related courses have you taken in 2023? How good were they and why? Let's see if we can come up with the list of the best possible ways to spend your time when you're done with this class, or maybe ones that you could start picking up right now. So we're going to go ahead and send you to breakout rooms of about 10 each, and go ahead and assign one person from each breakout room. Somebody raise their hand when you get there to sort of say, I'm going to kind of take a couple of notes on the things that people say. So when we come back, we can kind of debrief, we can get an overview of the best learning resources out there before we hop into some programming stuff. All right. So what LLM related courses have you taken in 2023? How good were they and why? Prompt is going to be dropped right in your Zoom room when you get there. All right. So we'll see you back in 10 minutes, meet some cool, nice people, and have a great time together. We'll see you back soon. Back, man, 2 hours, dude. 2 hours is tough, right? So we got room 1, room 2, getting into the groove. Milan, are you the one that raised your hand or somebody else?
No, I think it was Raul, man. He's our fearless leader, man.
Raul's the man. Okay.
No, not at all. It was like Milan dominated the place.
Yeah. Classic. Okay, Raul, what did we learn about what we should learn?
Yeah, we shared I think deep learning AI is a good source somehow, like to get a glimpse, and they provide some code also, right? So we shared about that. Milan shared the huge in thick huge, like GPT-4, right? Long list of things that he has internally in Amazon to keep it up with with everything that's going on out there. So we get scared somehow in this sense.
So deep learning AI, did you guys zero in on courses that you would take if you were really focused in on this stuff today? Raul, maybe, if you heard any that are specific.
Yeah, so it helped me, especially what you shared, and I think what you're about to share today also, Greg. I think what they did with this partnership with LangChain. So they did some short courses that they can teach all about the vector stores, and so like how to chunk and split documents. Also, the more formal course that they offer now, I think it's $30 to get a certificate, 3 weeks course at your own pace with AWS. And Milan also shared about it. I think they probably share with every Amazonian internally in the company, from even the delivery guy, probably.
Love it.
I think collectively everybody honed in on the AWS LLM class that's on deep learning. And then I think the other theme was for those short courses, I think everybody loved the short courses to always be learning little snippets of upskilling, but you know, everybody liked that they keep, dropping them. And it sounded like everybody here was following them closely.
Yeah. Very cool. Well, Hano, were you in charge of room 2, or did you just take notes like a legend, dude?
I took notes. I think another legend must also have been taking notes. Christos is always taking notes, but I didn't ask. So these are all of the things we mentioned. We also honed in the generative AI with LLMs by deep learning AI. A couple of other mentions, very interesting ones were given, like Elvis Savaria's prompt engineering course, and also a course from Cohere and from some resources from Pinecone. You can find them in the document I posted. But of course, we could not mention the Building with LLMs course, the people who took it, and following Chris and Ali on LinkedIn and YouTube and the content they provide.
Love it. Love it.
Yeah.
All right. Very cool. Well, I'm going to go ahead and send a list to everybody in LLM-01 session resources on Discord, so everybody kind of has that. But with that, we're going to keep it moving today. We're going to keep it moving, keep it grooving today. Let me go ahead and get this ready to rock and roll. And what we want to do is we want to talk a little bit about the development environment stuff that we got so much feedback on Monday or on Tuesday. And when we're talking about this sort of dev environment thing, many of you know this can be a huge pain, and absolutely just terrible pain to set this up. But we want to make it as easy as possible for you. And one of the things is that we have a lot of content, and we're really interested in finding a way to really thread it all together perfectly. And we're actively working on this, but we want to give you a glimpse into the way we're thinking about this exactly right now. You know, LLM ops, is this simply just ML ops plus LLMs? I mean, in a sense, yes. So if you basically get your computer set up and you've got the basics of Git working, whether that's GitHub or any other source control piece of software that uses the underlying technology Git, then really from there, you want to be able to make sure that you can create environments and you can store the appropriate libraries in those environments. You can get things up and running quickly. A really great way to, manage those libraries and packages in environments is using Conda, because they pre-build environments with all the libraries that you need. For instance, the pandas, the numpys, the things that we were having some trouble with on Tuesday. And then essentially getting that terminal open and interacting directly with your OS through text, not through a clickable GUI like you're doing when you're messing with Windows or when you're messing with Mac OS, but actually digging into the computer through text. And so being able to go into that terminal and get stuff done is an unbelievably important skill. And then using an interactive development environment, VS Code is the best practice tool today still. And then, of course, Jupyter Notebooks sort of fit in somewhere along the way. Today, as you're learning, OpenAI API is the LLM that you're going to want to start with. You can add open source LLMs from there. Now, in contrast to MLOps of 2022, really, when we're talking about prototyping something, we don't necessarily need to go and do the web application framework learning and the containerization learning, because when we use a tool like Hugging Face to just simply quickly develop something, that sort of abstracts everything away. And you can actually look inside what Hugging Face is doing when you do one-click deployments, and you can see it's creating a web application with Gradio or with Streamlit, and it's then also containerizing that web application for you before deployment. And then, of course, as we go from 0 to 1 in prototyping and we want to go into production, there are large cloud computing platforms out there that everybody's looking at. You may have noticed Databricks spent Well, they didn't spend $1.3 billion, but that was maybe they spent somewhere about half with real actual value in terms of the stock that they put in to buy Mosaic ML. But these cloud computing big guys are all sort of competing to kind of do everything for you. And those are going to be great options when you get to really scale production. Now, another way to think about this is you really want to think, okay, there is no perfect tech stack for everyone. There's a perfect tech stack for you in your context. And you're going to have a context that's either closer to someone that wants to build prototypes quickly. Maybe you're a startup founder, maybe you're a consultant, maybe you're in charge of an entrepreneurial team in a larger company. Or maybe you're an engineer that wants to be the 10x, 100x engineer, and you're just focused on code and infrastructure and tooling, and you want to be the person that helps your company or another company in the not too distant future scale to hundreds of thousands, millions, billions, beyond. And that's really going to provide a very different perfect tech stack, a perfect LLM ops tech stack for you. So what we're going to offer is we're going to offer just a quick overview of what we are recommending that you get started with today as you're coming into this. Our task is to align everyone as we get everyone sort of learning along a similar path, despite where you're standing and what you're aiming at. So with that, what I want to do is I want to go ahead and have Ali take it over and show a little bit about what this ML ops stack looks like, so that you can start making sure that you're aligned with this. And we're going to give you some time to sort of build out the stack all the way into what we started with on Tuesday, to really take the onus off of the way we made some of you feel earlier this week. Ali?
Thanks, Greg. Yeah, so can everybody see this? Zoomed in enough? Awesome. So yeah, if you go to the AI Makerspace repo, we have this LLM Ops Dev 101. And in this LLM Ops Dev 101, we're going to show you basically how to go through the entire environment. What we've done is we've made a list of all of the different commands in terminal here. These are ones that you're going to use most common, not all of them, but the ones that are going to be most common. We want people to be familiar with these. These are very, very necessary in order to, like, let's just say you need to remove a file because you've gotten duplicates or things like that. It allows you to have that power instead of struggling through it. So these are very direct. The tools we'll be using, Git, obviously. So with Git, you'll be able to manipulate all of these repos that we're putting out and also be able to bring in open source repos. It's a very critical skill to have in being able to manipulate that and being able to push and collaborate. Collaboration is big on this. So the other part here is also Conda and pip. We recommend using Conda because it brings in a lot of the different packages along with it, the scientific packages all around. And so these are going to be great for being able to pull them right into your repo and get them up and going. So basically, if you want to run your applications right away, we recommend that. And also, it's a lot easier to create these environments. So you can have all these different multiple environments and kind of like bypassing PMV. So in this, we're going to have you guys create the LLM Ops course environment, and then you're going to go ahead and activate it. And we're going to run with these necessary packages, NumPy, Pandas, Matplotlib, and Jupyter Notebook. And then we'll also require OpenAI. And so for this, Chris actually in a little bit will show a little bit more about this notebook and kind of like give a walkthrough. We have specific installations for Windows and Linux and Mac. The Linux and Mac ones are very similar, but the Windows, you do have to go through WSL and PowerShell. Going beyond this, here are all of the links for this is exactly the commands for installing all of these. And for VS Code, we'll have you go to this link. So for M1 chips, you may have issues on this. And so this is why we've supplied this specific M1/M2. So this is the Apple Silicon architecture installation for those that have Apple Silicon, and a lot of people work on Apple for software development. So this is specific to that. We'll also have these different extensions and for VS Code. So after you install VS Code, we have these specific extensions that you'll go through and install, and then we'll go through and get GitHub set up. So for this specifically, we want to make sure that you guys run through SSH. So generating that key and being able to authenticate. For those that already have access to our private repos, you already have done this. So in order to go through and be able to use terminal in that way to communicate with GitHub, you have to do this part. And we've supplied all directions here for that. Creating new repos. If you're new to GitHub, that we have instructions for how to do that, cloning a repo. And then we want you to get started with the Raka, your first LLM kind of app. And that is the one we did last time. So this is the link to that. And we'll share all these links in chat. But this is the Concepts 101, build your own Raka system you guys recently did. So that is what we want you to use for kind of like being able to get more familiar with Git in that way. Now, one thing specifically is that we have you guys using VS Code, right? And so with VS Code, it allows you to have a very, very powerful set of tools all around, extensions, everything like that all around. But then the other part of this is you want to really be able to work in text. So in other words, you want to be able to give all the commands because not everything has a graphical user interface to it. A lot of this stuff you have to actually type out in order to be a power user. And that's what we're focused on. We're focused on being power users that can get things done in a very, very clever, quick way. And so being able to understand those commands is very, very crucial. So with that, I'll pass it on to Chris to show you a little bit more about this OpenAI notebook. Chris?
Hey, thanks, Ollie. So I'm just going to share my screen. Hopefully you can see this. We're going to basically just walk through this notebook. It's very straightforward. A lot of you probably already have an awareness of how to do this, but if you don't, this is just to show you kind of the advantage of using the programmatic interface versus the actual just web interface or whatever for OpenAI. First thing, all we need is that OpenAI dependency, which you'll already have in your environment. And then we'll need to set up our OpenAI API key. I've hidden mine just so it's not exposed on the recording. But after that, we're just going to write a couple quick prompts to OpenAI's endpoints and see how their API works. There's a couple things that we need to pay attention to. Number one is this concept of roles, which kind of indicate or dictate how your message is going to interact with the LLM or how it's going to be perceived. So for instance, the system message is a great place to set things up, like what kind of behaviors you'd like to see the model take, everything like that. The assistant role is a great way to act as the LLM, which is very useful when we're considering things like few shot prompting or similar endeavors. And then, of course, our user prompt, which is our actual query. It's going to be like our question or whatever you want to call it. So when we're just using the user question and we're asking the LLM to do something, this is basically zero-shot prompting. We're just saying, hey, can you do this thing? And the instructive model is going to give it a shot. So we ask a question like, how much wood could woodchuck chuck? Woodchuck could chuck wood. We wrap this into this object, which contains both the role and the content of our message. So all of the OpenAI endpoints expect this role and content when it comes to their chat completion models, which you can see we're using here. And then we specify the model. We're just going to use 3.5 Turbo because it's awesome. And we send that away. We get this kind of very verbose response, which is fantastic because not only does it show us the ID, not only does it show us, what this actually is, when it was created, what specific model it used. It also shows us the response, the role of the response, the reason that the response stopped, and then most importantly for LLM ops reasons, we get the actual tokens. So we get to have very very specific line of sight to how much did this cost us, right? We know the specific model and we know how many tokens, and so we can compute exact cost, which is very handy. But when we're using this in like an application that users are going to see, we don't want to just blob them. So we're going to create simple, helper functions just to display it prettily. We're going to leverage the notebook's ability to display Markdown to do that. So this next example is just a simple example of the role. We've told this, through the system prompt that it's a Python programmer, and then we ask it to write a function, and it does so very well. So that's good. Good job, model. And then, we can look at the full response and get, again, how many tokens do we prompt it with, how many tokens did it use to complete, and what's our total count. And then finally, we have this final kind of example where we're using FewShot, prompting to encourage the model to speak like a pirate. Obviously, it can just speak like a pirate pretty well by itself, but it's just to showcase the pattern. We want to give it some examples of it doing the thing we want, and then query it with our prompt. And that's how we leverage the assistant role. And that's all how we do that through the OpenAI API.
Awesome. Awesome. So what we want to basically just make sure that you guys understand is that we are setting you up for success no matter what background you're coming from. We did a very aggressive sort of application process, but we know some of you still felt a little bit overwhelmed heading into Tuesday night and Wednesday. So I'm going to share in the session resources channel this view of Maven for you. And I want you guys to sort of take this in because this wasn't set up on Tuesday, but this is where you're going to come to be able to find everything. So what we just looked at is we looked at LLM ops, development environment, and first deployment. This is going to be available on Monday, the 14th. Obviously, that was a few days ago at this point. But this is sort of the first thing that you want to spend time on. And we're going to open up a breakout room shortly for you to look through this and feel a little bit more comfortable versus maybe how you felt on Tuesday. So the idea is when you can get that Git, that Conda, that Unix terminal, that VS Code, that Jupyter Notebook set up, and you can do simple deployments there, the next step is to get that OpenAI chat model syntax going. Beyond that, you're going to build your first RAG system and you're going to deploy it on Hugging Face. We are actively working to get a really succinct version of this and to do another event soon, probably within or shortly after this cohort is done. So this is the first thing that you want to be able to do. Beyond that, we talked about having supplemental resources related to fine-tuning. So you can find those directly here. This will pop up. We've got a great video from a previous community session that we did on the difference between prompt engineering and fine-tuning. And we've got those fine-tuning resources we showed last time. Additionally, the resources we showed last time are all here related to events that we've done on LangChain, associated codes with those events, including this one through the looking glass that has a lot of agent action. We'll see a little bit of that a little bit later. And then the Chainlit event that we did, there's also a video, there's slides, there's code. So all of this stuff is here. We want you to be able to take advantage of it at your leisure. And then of course, the community session from this week and also the community session from last week, in case you missed it, are up here as well. So with that, we're going to go ahead and open up breakout rooms for just about 15 minutes for you to be able to look at this. And the idea is very simple. We know many of you are at a point where you're not going to finish this. That's not the point. The point is to make sure you feel a little bit better about it. If you've already done this, then please take this as a give first community opportunity to do some teaching instead of some learning right now. It's really important that we all sort of get on the same page. And that's really the focus of this first hour, making sure that nobody feels left behind, because we are going to accelerate very, very quickly after the break into multiple streams with LangChain, agents, and a lot more complexity. All right, so let's go ahead and open them up for 15 minutes. We'll come back, have a short discussion, and then have a quick 5-minute break. See y'all back in 15 minutes. Pair programming.
Are we back?
Welcome back, everyone. All right. We are going to take a break in just a few minutes. But first, let's have some feedback from people. Was that complete waste of your time? Are you feeling better after it? Or you're like, okay, see some thumbs up, good. Raul, some smiles, Hung, some smiles, Deepak, good, Pano, good. A little heart action, very nice, okay. So did anybody have any questions they think or comments that may be useful to the group? Anybody?
I had one comment was I was trying to run the Mac instructions, the README, and it was taking too long to download the Xcode tools because I had an older version. And it turns out you don't have to do that stuff if you just grab utilities kind of on their own.
Oh, this is a great thing for us to bring up. We would love if you guys would open up PRs and help us improve anything that's ever in our GitHub. If you find errors, if you have, like Chris is there, Ali is there, we are constantly working to update these things. And because you're all straight legends in your own right, if you find anything that might be useful for the next cohort and the next cohort, of course, this is a very rough set of things that we still have to sort of squish together just right. But if anybody wants to help, again, we will be doing an event. We'd love to shout you out as being instrumental in that, tag you, help you ship and share, if that's something that, you know, you're finding useful along the way. Okay, cool. Well, we hope overall people are feeling a little bit better and ready for some agents when we come back, because we're going to open up some new streams. We're going to get a little more complex with LangChain, and hopefully this is going to be something that you feel a little more ready to tackle. We're going to take, for now, a quick 5, and then we'll come back at 8:03 Eastern, 5:03 Pacific. So we'll see you back in 5, and we'll get back after it. Thank you so much, everybody. We are back, ready to rock and roll. Here's what we're going to talk about today. That's how you felt just a minute ago, but that's over now. So welcome back. Just recall that we were talking about LangChain.
Hey, Greg, I think you're sharing the wrong screen.
Yes, of course. You think I'm sharing the wrong screen. Yes.
Just maybe.
Recall that we're talking about the LangChain. So many clicks for Canva. Here we go. And last time we looked at these diagrams. These are still relevant to us. Okay, we're taking raw source documents, we're chunking them, we're creating vectors out of those chunks using the OpenAI API embedding model, and we're putting those into a vector store, an index. All right, and then after we set that up, we hook up our vector store, our index, to the LLM, to GPT 3.5 in this case, where we were able to ask questions last time and get answers using things like the prompt template, which when we combine with our chat model, builds our LLM chain. All right, again, lots of resources for you to dig into the basics of this, but we are here to build really interesting things. And interesting things are often made up of small parts. Agents, there's a lot of ways to think about them in general. And agents, you know, from a book I was reading recently, I loved this idea. They might be molecules or neurons or species or consumers or even corporations, because molecules form cells, neurons form brains, species form ecosystems, consumers and corporations form economies. So agents are simply these smaller structures that, taken together, and many of them, form and come together so that they are now creating this phenomenon of emergence. We're now getting this emergent behavior. And this is a really cool idea, because if you think about, well, when are we going to get like the really crazy AI things? Answer, maybe we're not that far from getting them, because we have these agents now. And so this is a really cool sort of framing of agents. As we think about what an agent is actually doing in a simplified LangChain application, the easiest way to think about it is not emergent behavior in a very, very complex ecosystem. The best way to think about it is you've got a tool belt, and you're going to pull out a hammer when you have a nail. You're going to pull out pliers when you need to pull something. You're going to pull out the different tool for the different job. And so the tools in your tool belt, basically you decide which one to use and which one to take an action with. That sort of process by which you're selecting a tool, taking an action, that is kind of what the agent is in charge of. And what we're going to use today is we're going to use something called action agents. And that's simply, taking the action. Those are more interesting than the plan and execute agents, which are simply sort of following a script and following a map. Now, a recent event that we did, that again, this is on Maven, everything's in there, the LangChain event that we did, we went over this pretty quickly, to be honest with you. This was something that we did. We basically said, we said, what's the deal with the Cheshire cat? We're asking Lewis Carroll's documents. What's the deal? So let's take a look here. What is the deal? Well, when we enter our chain, our LangChain, the agent has a thought. I'm not sure about the details of the Cheshire cat. So it's going to take the action to go to Alice in Wonderland QA system. Then it's going to ask the QA system, what's the deal with the Cheshire cat? It's going to observe the Cheshire cat as a character in Alice's Adventures in Wonderland. It is known for its distinctive grin and ability to disappear and reappear at will. The Duchess explains to Alice that the cat is a Cheshire cat, which is why it grins. The cat also tells Alice that all cats can grin, but Alice is not aware of any cats that can. The Cheshire cat is portrayed as a mischievous and enigmatic, offering cryptic advice to Alice throughout her journey. Okay, you got that? The agent got it. It has a thought. Now I know the answer. Answer. The Cheshire cat is a mischievous and enigmatic character. Okay, known for its distinctive grin and ability to disappear and reappear at will. Now, in a complicated LangChain application, what you can do is you can make sure that you're not just able to ask questions, but you're able to have a conversation. And this ability to have a conversation, you can ask follow-up questions. You can say, well, what makes it, the Cheshire cat, enigmatic? And when we ask, the chain runs, has a thought. I'm not sure about the specific details that make the Cheshire cat enigmatic. Go back to the QA system. What makes the Cheshire cat enigmatic? Observation. It's enigmatic because it has the ability to grin, disappear, leaving only its smile behind. It also speaks in riddles and seems to have knowledge about the strange world of Wonderland. Its mysterious nature and unpredictable behavior. All right, we got an answer. Ability to disappear, its riddles, and its knowledge of Wonderland. Check, check, check. Good to go. What are some of its riddles? Interesting. Well, I don't know. So I'm going to ask the QA system. What are some of its riddles? There are no riddles. Well, that means there's no riddles that I'm getting as an answer. What should we do? We're going to pick up a new tool. In this case, our new tool is a backup Google search. I'm just going to Google it. We're going to Google riddles asked by the Cheshire cat. Boom, got a riddle. What road do I take? The cat asks, where do you want to go? Now I know the final answer. What road do I take? What is Alice's response? On and on. You can continue to have conversations with complex agents, on and on, because agents are freaking cool, right? Agents are pretty awesome. And this is exactly what we're going to see as we build out something a little bit more complex related to taking the Barbie reviews that we looked at and connecting them with some Oppenheimer reviews. So it's time for the Barbenheimer agent demo. Chris, off to you.
Yes, thank you, Greg. Okay, so we are going to, I gotta share my screen, sorry. I'm going to share my VS Code. Please let me know if you can see this. And I will zoom it in. So this is what we'll be doing today, which is building ourselves a system that will leverage agents in order to let us kind of communicate across multiple sources of information, multiple indexes, the whole kit and caboodle. So first things first, as always, we're going to grab some dependencies. So we just want to pip install LangChain OpenAI. Those are our core dependencies for today. We're going to be relying on that OpenAI endpoint as our LLM to power the agents and our retrieval systems. We'll have to put in our API key, of course, and we're going to use 3.5 Turbo. We could use GPT-4, but 3.5 Turbo will do a good enough job. First thing we're going to do is grab some additional information. So last time we had just the reviews for the Barbie movie. Today, we're going to also grab information relating to the Wikipedia page, so we can get some more context and semantic information than just reviews. And that's going to help us to answer questions better. We're going to leverage the Wikipedia loader to do this, which is just part of LangChain, right? LangChain has a number of adapters for multiple different data sources. It's very, very much a expansive ecosystem at this point. Once we have both and then this is the CSV loader, should be familiar from Tuesday. You'll notice that I set the document characters absurdly large here. This is just to guarantee that we collect all of the information from the Wikipedia page. We don't want to lose context. So that's why I've done that. Next up, we're going to build 2 text splitters. We're going to have, I'll zoom this in just a little bit. I see some people leaning in pretty hard. So I will, hopefully this makes it a little bit better. The idea here is that even though we're going to use more than just the Barbie information, we don't actually need to make these splitters twice, right? We know we're going to take Wikipedia pages in, and we know we're going to take CSVs in. So we're going to go ahead and put those in here, which we can repurpose later. One of the things that we're going to focus on for our Wikipedia text splitter, and this is how this is that piece where knowing your data really comes in handy, right? We're going to use the recursive character text splitter, and we're going to split on these tokens or these character sequences. And the reason we're going to do that is so that we keep the most coherent chunks of information together, right? So we know that Wikipedia has these headers that contain information. So it'll say like, plot or cast in the Wikipedia page. And so we want to first split on those and then split within those chunks. So we can keep as much information together as we can. And then we're going to do the same thing for CSV, but because we don't have this particular character, there's no point including it. So we're just going to use the new lines and then spaces. So we know that new lines mean new entry, and we know that spaces occur between words. So we're not trying to rip words apart here. You'll also notice that we have no overlap for our text splitter for Wikipedia, and we have some for our CSV. This is because we're very unlikely to run into a situation where we are we're worried about the overlap within the articles. The semantic information, the way we're retrieving it, you're going to see later, will help alleviate some of that concern. Speaking of, we're going to set up our embeddings. So, just like last time, we're going to use the cache embeddings. This is just to give us a little bit extra late inference or reduce inference latency and make sure that we are not wasting our users' time or tokens. And we're going to be using that face vector store again as a retriever. This is straight up just from Tuesday, so we'll re-implement that there. The kind of flavor we're going to add to the Barbie index and retrieval system is we're going to use this ensemble retriever, which combines both a dense search and a sparse search of our text, and then applies a re-ranking algorithm to the results in order to get us the most relevant information or potentially relevant information. You can read all about the specific method in the paper, but the idea here is that we don't want to just rely on the semantic search, right? We might lose some things. We might lose critical information, and it's easier if we use this re-ranking algorithm to help us combine two different methods of search in order to get the most relevant information for our end users. So we're going to use the BM25 retriever, and we're going to use and this is a bag of words method, just to be clear. And then we're going to use our classic face vector store, which we set up above. And then we're going to add these weights. One thing that is important to remember when you're going through this yourself and writing filling in the kind of boxes, we need these to sum to 1, or else it'll throw an error. So those are the weights. How much weight do we give each retriever? So we give the sparse retriever a little bit less weight than the dense retriever in this instance, just because we really care about that semantic information a bit more than we would care about just keywords or word inclusion. We're going to also use the create retrieval tool because while we're not yet building the overarching agent, we can just still use agents. I mean, it's LangChain, we've got agents. Let's use one for this as well. So we're going to create these retrieval tools. We'll build one both for our ensemble and for our CSV. So there are 2 separate streams that we're condensing into one through this agent at the top layer. And we're going to use LangChain's super simple syntax to create this agent, which is where we create conversational retrieval agent, and then we query it by sending it input text. So it's just an object with input as the key, and then whatever your query is as the value. LangChain has different retrievers. Can we use them in ours? You can use whatever retrievers you want. Yes, absolutely. If you have specific vector store or retriever combinations that you most enjoy or have familiarity with or want to use, go for it. By no means are you bounded by the example that we're using here. And then we see the first instance of this idea that Greg was talking to us about earlier, which is, we have this agent executor chain. The important thing to remember about LangChain's agent system is, for the most part, they're built on what's called a REACT system, which is a reason action system. So what this means is that you prompt the LLM to reason through the problem and decide which tool would be great to use. And then you have an active component, which is going to actually leverage the tools that we need to use. So you reason about the problem, come up with a plan of action, and then you have this executor, which is going to actually call the code, right? So it's going to call the specific chain or call the specific retriever. So in this case, what we have done is we have an agent that we're sending a query to. It's going to, with the inclusion of the tools that we have in its tool belt, which are these 2 different retrievers that we've set up here, it's going to reason through and decide which tool it wants to use, if it needs to use a tool. And then it's going to let the executor know that the executor is going to take the action. Their action is going to be to call one of those tools, or say, hey, actually, we don't need to call a tool. So the executor just chills. And then the tool will return a response to the reasoning part again. So that's the reasoner half of the agent. And it will make new decisions with the new information, as well as that process. It also has something that we'll look at a bit further down in the notebook, which helps it to think through, quote unquote, its decisions. But as you can see, we enter the executor chain. We decide to invoke public reviews with Barbie movie, and then we retrieve relevant context. And then the LLM spits out a response, which is, based on the public reviews of the Barbie movie, opinions are mixed. So the idea here is that it is intelligently, quote unquote, again, deciding which tool to use, right? Which tool is most relevant to our query? Do we want to look at Wikipedia information, or do we want to look at CSV information? And we have another tool in which it decides to use Wikipedia. So in the first query, we asked, did people like Barbie, or did they find it too philosophical? And then the second one, we asked, what is a very quick summary of the plot of the Barbie movie? So it is able to dynamically decide which tool to use and leverage it. Leverage it there. We'll zoom in a little bit, Joshua, into where the reasoner agent is kind of getting how it works from. But great question. Next up, we're just going to do the same thing with Oppenheimer. So we've already done it. So we just we use what we already did. Let's go. But instead of that system we had before with the agent that was deciding between the two tools to use, we're going to showcase a multi-source chain. So this is a chain that's actually using two different sources at the same time. It doesn't have to be limited to two. You're basically only limited by your context window here. But the idea is that instead of having an agent make decisions on what tools to use, we're going to just indiscriminately query both of our tools. And we're going to collect all that feedback and then let the LLM come up with a response based on both provided feedbacks. This is an excellent method to combine two kind of disparate sources of information that you want to have answers from both sources for. So if you definitely want the model to have access to both of the context streams, then this is a good option. In this case, of course, we're taking our CSV information and we're taking our Wikipedia information and we're giving both back. And the LLM can decide what to use. LangChain talks about this, and you can learn more about it in a paper. But one issue with kind of these longer context window, context window, prompts is that we actually lose some information from the middle. So there's some strategies you can take to overcome that, but we'll talk about those a little bit later on. And then we can use LangChain's pretty dope kind of pseudo language that it has, which is this format here. I wouldn't spend too much time really internalizing this right now, but it is useful to see. And the idea here is that we're saying source one is going to be determined by sending the question from the input to this retriever. Source two in our prompt is going to be determined by sending the question to the CSV retriever. And then the actual question in the prompt is which is here, is going to be determined by, again, just the question. And then we're going to send that to the prompt and we're going to send that to the LLM. So this is just another way to write LangChain chains, essentially. Yes, there are limits to the number of sources for context windows. So like if you have big chunks, right? So if you use 2000 length chunks, tokens or characters, whatever it is, you're going to be able to fit less of those into your model all at once, since models have limited context windows. So it's not yet a perfect science to determine exactly the right balance of all of these things, but it is definitely the case that you need to be wary of how much information you're packing in here. And we can invoke this kind of the same way, right? We can have it retrieve both and then make a decision. So this is just a retriever that wraps two sources. And now we can create our agent. This part is strangely straightforward, right? I mean, it's very effective in practice, and we're going to get into some more complex implementations that maybe are less simple to implement. But just getting an agent going, LangChain does a great job of making it straightforward for us. So we have to include this helper function just because we're using the multi-query kind of pattern. That's the only reason. But the idea, like Greg said, first thing we're going to do is just make our tool belt. So this is our tool belt. We put in two different kinds of retrievers. We have the Barbie retriever, and we have the Oppenheimer retriever. One of the things that's interesting to note here is that these are combined sources of information, right? So we actually have 4 sources but we're piping them in to 2 just to avoid glutting the tool ecosystem up too much. It doesn't really affect performance, but it is good to keep in mind that you can give structure to your indexes through this pattern. But yes. Now, someone was saying earlier, how does it decide which tool to use? Well, that's what this description is very useful for. So we have a description of the tool in natural language, which is going to get piped into the LLM. The LLM is going to look at the descriptions available to it, and based off those descriptions, it's going to make the decision on which tool it feels is most relevant to the user's query. So basically what we're feeding it is this description, and then our executors, our agent executor, the thing that actually takes action, is the one that's going to execute the code. The actual agent prompt is fairly straightforward. Have a conversation with the human, answering the following questions as best you can. You have access to the following tools, at which point we would inject the descriptions for our tools. And then it gives it we give it this kind of prompt that says begin, like let's go. And then we're going to give it a question, as well as give it this scratch pad. The scratch pad is important because it's kind of what the agent uses to quote unquote think. So this is where it's doing the reasoning, right? So it's going to look at some text and then make decisions off of that text based on previous prompt results. So the agent scratchpad is key to the whole thing. It's what lets us do that reasoning part, or at least facsimile of reasoning. And then we create a zero-shot agent, right? So this is a zero-shot agent. We just give it requests and it does stuff. So there's no few shot here. And then we are going to include our prefix, our suffix, and then our input variables, which just align with these objects here. And then we have our LLM chain, which is making the reasoning agent's brain, right? So we give this prompt set, or zero-shot agent prompt set, a LLM, and away we go. And then we attach it to an executor, which is the thing that runs code. Again, we let the executor see the tools, and we want both of them to be verbose. We get lots of output, and then that's it. We're done. We're querying an agent. We can see, entering new agent executor chain. Thought, I need to find information about the Barbie movie. Action, Barbie info. Action input. What did people like about the Barbie movie? And then we enter a new chain. This chain is the Barbie retriever chain. At which point we do the same thing. And then we get an observation. The observation is what it's learned from the tool. And then we have a new thought, and that thought is, I'm done. And then we get a response. You'll see in this more complicated example, slightly more complicated example, where we query both tools, right? So we enter the chain. We ask it, did it share similar themes, Barbie and Oppenheimer, right? We enter the chain. We say, first of all, let's learn about themes from Barbie. We'll get that from Barbie info. We get that back. Then we say, okay, now I have the Barbie stuff. Let's get the Oppenheimer stuff. We go to that tool. We get the Oppenheimer stuff. And then we combine those together, and the LLM parses those and provides us with a response. We said, yes, they both have specific themes and ideas. The Barbie movie is often focused on friendship, adventure, self-discovery, empowerment, the importance of being true to oneself. They also pervert, we go on and on and on and on to say that they're pretty different, actually. So, which is fair and true. Though they could be a little bit similar. The LLM's not making that very tenuous connection, which is kind of what we would hope. So that's how we build the agent. And there you go. The chain's printing out its thought process with the verbose equals true parameter. Jay.
All right. Well, with that, just curious to launch one more poll. I'm feeling the polls today. We're opening up breakout rooms in just a minute. We're going to pair you up with we're going to pair you up with one new person. And the idea here is you're going to start your homework. So essentially follow the assignment notebook and the associated README in the GitHub repo. There's also the assignment on Maven and start building your Barbenheimer QA system. And let's see if we can come up with the most fun question to ask it after you build it. Wow, check that out. Lol. Okay. Who's the one? Who's the one? I mean, I have. Chris has. Sarah, have you seen both?
I've seen Barbie. I haven't seen Oppenheimer. I'm not old enough.
You willing to admit?
That I'm not old enough to see Oppenheimer? Yeah.
Who's willing to admit how cool they are that they Milan, was it you?
That was me, man.
Yeah. Chris,
Yeah,
well,
I'm an old man, dude.
All right, 20 minutes. Let's hang, get started. We're gonna send the prompt again, but it's just getting started with that README. It'll be in Discord. It will be in Zoom. Have some fun.
Bring the Kenergy.
Bring the Kenergy. Can't get enough.
I beach.
Back, everybody. Sounds like there's some good discussions going on. I see cameras on. That's a good thing. So again, thumbs up, thumbs down. How we feeling after that? Good. All right. Middle, mid, roughly mid. Okay. All right. Well, I think this is part of the game. I think we want you to feel about mid right now, just not thumbs down. So if you have questions, please post them in the Discord so that anybody can field them. Chris is obviously here. Ali is here. Juan is always here. The up and coming legends, Bo and Christos, are always in there as well. And now Milan that we have in the house. I imagine he's going to be in there as well. Milan, we will get you that Discord invite. And anybody that maybe had a little bit of registration issues, we're going to get you that Discord invite as well. Make sure that you're good to go. So we just have a few things before we sort of close out for today. First off, we want to go ahead and just kind of review where we've been. This week, we probably should have started off with the LLM Ops Dev environment, but really getting set up properly is always going to be the first step. We talked about retrieval augmented generation. We learned how to develop some question answering systems. You're going to see RAG out there. Everybody's talking RAG, but really there are some slight differences between retrieval augmented generation as originally conceptualized in the archive paper versus retrieval augmented question answering. The popular term is becoming RAG, but you should familiarize yourselves with the subtle differences. Chris is available tomorrow night to nerd out the entire office hour on that if you guys would like. Question answering is always more impressive with agents and multiple streams and multiple documents, multiple document types. The assignment number 2 is due the same time as the assignment number 1 by Monday night, Eastern time, 11:59:59. Don't forget to build, ship, and share. And next week, we're going to pick up with agents, and we're going to add a little bit of interesting quantitative vibes to what we've been doing with question answering. So we're going to be able to connect some CSV type data, some SQL data really nicely to some contextual language data using Llama Index. So this is the next tool that we're going to add to our stack.